Hello everyone, my name is Daniel and I'm a programmer and an artist. This video is going to be about modular modifiers, or it's probably going to be the first in several videos where I try to make a modular modifier system. And what I mean by modular is that for whatever it is you're trying to do, so I'm thinking of it, so my plan in this case is for making some modifiers that make a path or road sort of elements that use actual 3D elements on top of a terrain rather than just changing a texture in the shader. So that's what we're going to try to make. But the way I want to approach doing that is in a way that can make as many types of roads as possible with the tool set once I'm done with it, rather than making a very specific tool that makes whatever type of road I want to make right now, but then the next time I want a road, I have to make a completely different one. So the way I do that is by making the modifiers modular. And what that means is they all work together. They're all trying to make the same kind of thing, but each piece does a small portion of it, and you can swap and mix and match the modifiers to make different kinds of roads. If you add enough different parts, then there's a lot of possibilities. So for an example, I've been working on these fence modifiers. They use that system. And so in total, all of the modifiers make a fence, but each individual modifier makes the posts in this case, or this one makes the pickets. This one only makes rails, but then you can add additional modifiers. I could add another rails and put different sized rails in between. And so to do that requires tagging and keeping around parts of the geometry that normally wouldn't be considered like the final output rendered geometry. So I'm going to show how to do that, how to set up tagging to save and retrieve geometry, extra geometry in the geometry that you're processing with your modifier stack, how to think about making a tool in pieces, and hopefully we'll make some cool stuff as well. So to start with, you need to know what it is you're trying to make. So in this case, I've decided I'm trying to make something that can make roads and paths. So that's the end goal, roads and paths. And the other thing you need to decide is what your input is going to be. In this case, the input that makes the most sense to me is a curve. Using a curve allows us to do several cool things. One is being able to scale the radius of the curve. That'll add some nice control. And it's very easy to draw them, where you can just have a point and extrude it out to make roads. And that should be an easy workflow to sort of get used to following. Sometimes you can make some assumptions about what you're working with. So one assumption we could make that would help a lot is that the roads are essentially two-dimensional, projected onto this 3D terrain. That'll simplify a lot of things. If we do that, it won't allow us to do like bridges in the same object. So if we wanted to have this road here crossing over like this, it would process that as an intersection rather than using the height. But there are ways around that. You could separate this into a separate object. And so we're going to make that assumption that it's only two-dimensional, and that will introduce the limitation of not being able to do over-unders. The next thing to think about is what kinds of control geometry, which are typically like curves or points, we might want to save and pass through the modifier stack. And one that immediately pops into mind is the original curve. That's kind of obvious. But also, we might want a curve that shows like the boundary of the road, which would be like two parallel curves, roughly parallel curves, on either side of the original input curve. We also might want some points where there's intersections. I was also thinking a little bit about what kind of tools might be in the set, and how they could interact with each other. So one that's obvious is we'll need a starting point. So I typically call that the base node. So it'll be like a road base or a path base. And that could have some useful controls for adding a uniform randomness to all of the modifiers that follow it, or scaling the overall radius or width of the roads or on the curves. Those could be some useful controls. We're definitely going to want one that can sort of put a road surface down. So you could imagine we'll need something that can fill in this with a mesh. Once we have that mesh surface of the road, we might want to be able to extrude out from the edges of it even further. So I'm thinking you can maybe add additional shoulders, as many as you want. And so we could have this edge be tagged as something that is like the road edge. And then every time we add another shoulder onto it, it gets moved out further. And then we add another shoulder and that outer edge gets moved out. So that could be something we could do that could be interesting. And then on those sort of shoulder sections, you could either fill it in with a mesh and put something on there, or you could put a railing through it, or you could do light poles. I don't know. And then the idea is sort of that each of those could be a configurable size. Another tricky problem that we'll have to figure out how to solve is intersections, because if this is two separate curves going through here, we can't just do a curve to mesh, because we'd end up with this mesh going through here, and then we get another mesh going like this, and they'd be all intersecting and just make a mess. So I have an idea of how we could solve the intersection problem by using volumes. So we're going to experiment with that. Anyway, so that's my rough idea. I haven't really planned it all the way out. I tested a little bit of this just to make sure it would work, but as far as what exactly all of the modifiers might be, I don't know yet. The first thing I definitely want to do, though, is make one that can snap the curve to the terrain and determine the width of the road. So we'll start with that and see where we go from there. I know I'm also going to want to be able to do intersections, so let's also add in some extra curves in here for some additional roads. Something like this. And then let's create a new geometry nodes modifier, and we'll call it road base. And we need to go to hello. All right, we're back where it crashed. So let's make a new modifier. We'll call it road base. We need to switch to our geometry nodes editor. And then let's add some extra curves in here for intersections. All right, so we've got some curves. We have some intersections we need to solve, and we've got a geometry nodes group. So the first thing in here that we'll want to do is probably resample the curve. And let's resample it to a length. I don't think we need to expose that right now, so we'll leave it like that. All right, once we have the curve in there, we're going to want to convert the points into a volume. So we'll do a points to volume. And we're going to want the resolution to be based on a size. We can set the density really high. And the size should be pretty small. Now, the downside of this is that the bigger your roads are, the less well this will work. Then this radius here should be the radius value. So that allows us to come in here and scale the size of the road. Next, before we do this, in case there is shape to our road like this, we're going to get rid of that. So let's do a set position. This is where the benefit of assuming that it's two-dimensional helps us. And the downside of that is we can't do over-unders. So we're going to set the position of the position, but we want to multiply that position by x and y1, z of 0. So now it's completely flat at 0 on the z-axis. Then we're going to convert our points to a volume, and then we're going to convert the volume to a mesh. And we should use the same size that we chose for our boxes here. And we can expose this to the input. And we could call it like remesh size, or remesh resolution. Threshold and stuff, I think It's probably fine where it is. Next, we want to delete all of the edges in this, except the edge at 0. So we're going to delete geometry edges, and then we're going to say the position, separate XYZ, Z does not equal 0, and we're going to delete that. And so that leaves us this curve here. Let's do a set position. So that's my idea of how to handle the intersections. So then you can just put this curve wherever it makes sense, coming into the... So when you convert the points of the curve into a volume and then that into a mesh, all of the intersecting parts get lost because they're just inside of the volume. And then when you convert, when you delete all of the mesh except that part at 0, which it seems like the way that the remesher works, there will always be an edge at 0 if you flatten your input. Then you can just take that edge and use it as your new boundary. And then we have a contiguous edge that goes all the way around the outside of our roads. Another thing that would be nice to do here is to clean it up a bit. So let's actually do a merge by distance. And we'll set this to something like 0.25 or 0.5. And that will smooth out the edges a bit. You could even set it higher, probably like 1. I don't know. Again, one of the things I'm often thinking about when I'm building these is what parameters should be exposed. So is this merge distance something that you would want to tweak, or is having it set to a constant value fine? I think it's one that we might want to tweak, but for now we'll leave it. Then we can convert this back to a curve. So we can do mesh to curve. And then we can set the spline type on the curve to a catmull rom. That'll smooth it out even more. Another thing we could play with is setting the position to a blur attribute node. And that also can smooth it out, but that can really lose detail fast. So I think actually increasing this merge distance to 1 might be a better option. Now I think something else that might be kind of cool to do here is be able to choose if we want to randomize the edge at all. So after we've merged by distance, let's actually resample the curve. And we'll resample by a distance or a length of 0.5, which will essentially double the resolution of the curve, give us some extra points. And then let's set the position of the points in that curve to an offset of a noise texture. We want to use the color, and we don't want to normalize it. And then we want to multiply that color vector by x and y, but not z, which will probably doesn't really matter, but we'll do that. And then we want to scale that vector, and this should be an input, so we'll put that in the group input, and we'll call it noise. It should be a factor, and we can choose like a default of 0.25 between 0 and 2, single value. Then we want to be able to control the scale of this, so we can control the size of the noise. So let's expose this to the input, and we'll call it noise scale. Noise scale. And again, this should be a factor 0 and 2, single value. That way it's just easy to slide. Actually 0 and like 1's probably fine. You can also type in this any number you want. So it's not like you're limiting someone to forcing them to use some values that you think are right. But this way it makes it easy to slide and control. So now we can add randomness to the edges of the roads as much as we want. So let's set it to 0.25, 0.25, which I think is what I had the default to. And it's optional, you can turn noise all the way down. Another thing I want to do is delete the extra part that sticks off the edge of the terrain. So to do that, and we want to snap to the terrain. So to do that, I'm going to need a collection. This should be exposed to the input. And we can call this the terrain or ground. Should be a relative, and we want to realize the instances. Then once we've realized the instances, we want to do a raycast. And we want to raycast from the source position of position. And then we want to add like 50 on Z to make sure it starts above the terrain. All right. Now we have the raycast. We're going to want to do a couple things with it. The first thing we want to do with it is delete the overhanging parts. So let's do a delete geometry, not is hit. But before we do that, I actually want to capture this so that we know where those ends are. So let's do a capture attribute. And we'll do, we'll blur this attribute as a float by 1, and that will extend it 1 vertex or point in the curve further than it was before. So if we view that, oh, we need to select our terrain. So if we view that here, you can see this is what it looks like right now, and if we turn the blur down, you can see it moves outwards 1. So then, once we have that captured, and we can capture it as a Boolean, then we can use the original one to delete the points, but that'll leave us 1 vertex, or 1 point in the curve still tagged as being off the edge of the mesh, and that way if we ever want to delete that edge, we can. I'm not sure if I like the catmull ROM. And actually, this should probably go here. Yeah, I think I like it better without the catmull ROM, so we'll move that back. Now that we have this, we want to tag it as a control that we might want to use. Also, I don't think we want to capture this attribute. We actually want to save it as a named attribute. So let's do named attribute, store named attribute. Should be a Boolean value on the points. And we'll plug this into here instead. A Boolean value. And we'll call it road ends. So that way we can retrieve that later in other modifiers if we want to use it. Next, we want to store another named attribute, and we want it to be an integer. And we'll call it road ID. And we'll call this boundary curve will be tagged as 1 in the road ID. Then we also want our input geometry, and we want to store the same named attribute on it. This will be our centerline curve, and we'll tag it with a 0. Once we've done that, we can join the geometry together. And in future modifiers, we can separate the mesh by the named attribute of road ID, where that value, that integer value, equals 0 or 1 to get the different parts of the mesh. And each additional part we add through the modifiers will get us its own unique ID. So the surface might be ID 2, and then the curbs might be ID 3, etc. And that's what enables the modifiers to be in a stack, modular, where you can add and remove the components as you want, so that you can customize the output that you get as much as possible by mixing and matching the different elements that you want. The other thing we should do here, so while we're at it, is to snap this to the terrain. So after deleting the points here, we should use a set position. I don't know, it also might be helpful to snap the input curve to the terrain. But I don't know if we want to do that or not. Anyway, we can just take the hit position from the raycast and plug that hit position into the position of the set position node, and now our curves are snapped to the terrain. All right, I think that's where I want to stop for now. Next, I want to figure out how to add points at the intersections and maybe mesh, fill in that outline boundary with a mesh. So yeah, we'll see. Anyway, hopefully this is interesting and will be a useful set of videos. If you have any thoughts, let me know. That's all I've got for this one. Thanks for watching.